You know, we usually think of AI as this master of cold, hard logic. But what happens when you throw a challenge at it that's all about pure creativity and strategy? That's what we're diving into today, a fascinating case where an AI had to learn not just how to play a complex game, but how to actually invent a winning strategy from scratch. So, that brings us to the big question, right? Can an AI really go beyond just being good at playing a game and actually design a totally new winning strategy? Answering this, well, it pushes the boundaries of what we even think AI is capable of. Okay, so our testing ground for this is this super popular digital card game, Hearthstone. And the creative challenge it presents, as you're about to see, it is absolutely mind-bogglingly massive. At the very heart of Hearthstone is something called deck building. And look, it's not just about picking your 30 strongest cards. Oh no, it is a true art form. You have to find cards that have synergy, that work together to create these powerful combos, all while trying to counter whatever your opponent might be planning. It's a really deep, strategic puzzle. So, to give you an idea of the scale we're talking about, get this. If you only use the first two sets of cards ever released for the game, there are 1.42 times 10 to the power of 35 possible decks you could build. I mean, to put that into perspective, that number is bigger than the estimated number of atoms in our entire galaxy. So how on earth can an AI even begin to search a space that vast for good ideas? Right, so the goal here wasn't just to find the one single best deck. What the researchers wanted was an AI that could discover a whole collection of different successful strategies. To do this, they started with an algorithm called Map Elites. The key phrase to remember here is quality diversity. See, unlike a typical AI that's just trying to get the highest score possible, Map Elites is designed to find lots of different kinds of solutions that are all high quality in their own unique way. Here's a great way to think about it. A normal algorithm is like a casting director looking for the single best actor for a role. But Map Elites, it's more like a super savvy talent scout trying to build a whole roster of stars. It wants the best action hero, and the best comedian, and the best dramatic lead, because it understands that best can mean a lot of different things. So how do you define diversity in Hearthstone? Well, the AI looked at a couple of key characteristics. On one axis, you've got game length. Does a deck try to win really fast? That's called an aggro style. Or does it try to play a long, slow, strategic game, which is called control? And on the other axis, you've got hand size. Does the deck like to hold on to a lot of cards for big combos? Or does it play them out as fast as it gets them? The AI's job was to find a winning deck for every single spot on that strategy map. Okay, this all sounds absolutely brilliant in theory. But in practice, the researchers immediately slammed into a massive, almost crippling problem. The catch is that testing even a single one of these ideas in this universe of possibilities is incredibly slow. And here is the number that just stops you in your tracks. You see, Hearthstone has a lot of randomness built in. You know, what cards you draw, what your opponent does. So you can't just play one game to see if a deck is good. No. To get a reliable feel for its win rate, you have to simulate it playing 200 full games. And that's for every single deck the AI wants to test. The consequence is simple, and it's brutal. The entire search process just slows to an absolute crawl. You just can't explore a universe of 10 to the 35th possibilities if every single step takes that long. And this is what you get. This heat map here represents all the different strategic styles the AI was trying to find. After a massive amount of computing power, you can see it barely found anything. Most of the map is just empty. The standard approach was just not up to the task. Not even close. Clearly, they needed a shortcut. Some way to get a quick guess about a deck's potential without running that 200-game simulation every time. And this, right here, is where the hero of our story comes in. They introduced a second AI, which is called a surrogate model. Its entire job is to be a fast, lightweight stand-in for that super slow game simulator. You just show it a deck, and it uses everything it's learned to instantly predict how well that deck will probably do and what kind of style it'll have. I absolutely love this analogy. The slow 200-game simulation, that's like polling the entire audience after a movie premiere. The surrogate model, on the other hand, is like an expert movie critic who can just look at the script and the actors and make a really educated guess about how the movie is going to do. It's not going to be perfect every time, but it is incredibly fast. So this gives us two AIs. The slow but accurate simulator, and the fast but predictive surrogate. The real magic happens when you get them to work together in this really clever feedback loop. So this is the full system from the research paper. It's called DSA-ME. And I know, it looks incredibly complicated. And hey, it is. But the core idea behind it is actually a really elegant loop. And we can break it down into a few simple steps. Okay, here's how it works. First, in what they call an inner loop, that fast predictor AI explores thousands of deck ideas on its own and creates a map of what it thinks are the most promising and diverse strategies. Then, we take only the absolute best of those predictions and run them through the slow but super accurate simulator. This gives us real ground truth data. And now for the crucial part. We then use that real data to retrain the predictor AI, which makes it smarter. Then the whole cycle repeats. The predictor gets better at guessing, which means it proposes better decks, which gives it even better data to learn from. It's a genius loop. So the billion-dollar question, does this feedback loop actually work? Well, let's take a look at the results. And here it is. This is the money shot. On the left, you see that sparse, kind of sad-looking map from the original slow method. And on the right, the results from the new feedback loop system. The difference is just staggering. It's not just a little better, it is a completely different world. The new AI discovered this huge variety of powerful and distinct strategies, filling in that map beautifully. The numbers back this picture up perfectly. If you look at cells filled, which is how we measure diversity, the new method more than doubled the number of unique strategies it found, and the QD score, which measures overall quality and diversity combined, saw an even bigger jump. It's almost 2.5 times higher. This is just a massive, massive improvement. So the huge takeaway here is this. By having a fast, predictive AI work together with a slow but accurate evaluation, the system could finally effectively explore that impossibly vast universe of strategies. In the end, it found more decks, better decks, and a much wider variety of decks than the slow method could have ever hoped to find. And this really brings us to the final big picture thought. This isn't just about video games, you know? This technique, using a fast predictive model to guide a slower, more powerful search, has huge implications. If an AI can master something as creative and nuanced as game strategy, what other complex design problems could it solve? I mean, think about things like drug discovery or designing new materials or maybe even creating art. It really makes you wonder, what is the next creative frontier for AI to master?